Hey everyone. In tonight's session, I'm going to show you in the series of Linux how-tos. I'm going to show you how to explain the Linux file system. And the Linux file system is similar to every other operating system, another file system that supports a lot of different type of file system. So with this topic, let me just go to my YouTube channel first and show you the video that we already provided to you in the Linux series of how-tos. We have about 7 videos already. Video number 1 was, if I just go on this one and go through a slideshow. On video number 1, we were talking about the how to power on the operating system, and then that would be Linux, Ubuntu, Red Hat, or Rocky version. And video number 2, video number 1 actually we showed you the OS version information, log out and log off from it safely. And then on video number 2, we installed Rocky Linux as a virtual machine. And this is also how to do that one. On Linux video number 3, Linux how-to, we talk about the graphical user interface. And then video number 4 was the terminal command line interface for Red Hat, Rocky, and Ubuntu. And then video number 5 was the hostname details. Video number 6 was the user and group details. And video number 7 was the kernel and shell. The kernel is the core part of the operating system, and the shell is the interface to the kernel by the users. And then today we're going to talk about video number 8, which is the file system. So without further ado, let's get into the virtual box and start the power on the My Web University Linux Ubuntu development virtual machine. I'm going to start that one, and then we are going to demonstrate further the file system of Linux once it's started. So on today's topic, I'm going to discuss a number of different methods for the file system that you can understand what a file system is, what is the difference between the raw disk and a disk that is running a file system on it, and I'll show you all of that. And also different type of files that are stored on the system, whether binaries, data files, database files, source files, ASCII, HTML, text, executables, all kind of files, images, which are data files also. So we are going to look at this Linux Ubuntu. I'm going to open a terminal here first, and then by right-clicking on the desktop, I can click on Open Terminal. This terminal comes in. I'm going to make it a little bit bigger on the size so you can see it better. And then the disk information details is fine. It is showing user at my university, and I'm currently at the desktop directory. Now I'm on my home directory. As you can see, $ home is pointing to the same place where pwd is pointing at this time. And then get an environment, get ent password Wahid, and then ID of myself -UN is Wahid. So who am I also shows that Wahid. That information, we can look at it. And the reason I'm doing that one is because later on I'm going to show you how to just on Ubuntu use the file system between Windows and Linux Ubuntu, and share a temporary file system on the Windows, and allow Ubuntu to see it and then modify the file either on Linux Ubuntu or vice versa, or the host operating system, in this case Windows. So that's why I'm showing these user information here. And then at this time, I'm going to first show you a couple of things about the file system. So if you look at df-h by itself, which shows in human, -h means human readable, this format or the disk utility that it is running. This is just showing the partition for every file system that it is created, the root file system, the /dev shm, runlock, and all the other ones that are there. Basically, the file systems are either XFS, UFS, or NFS, or ZFS, FAT file system, and TFS. There's a lot of type of BATA file system, and a number of them. So in order to know what is this OS supports, so if I say uname -s, this is a Linux kernel, and then uname dash kernel name will also show -s Linux stuff. And so if you do a uname -a, as previously I provided this information, it also shows the build version of the Linux, and uname oh, it shows you the GNU Linux operating system. Uname -r give you the revision or the build. So why am I showing you these ones? Because on this system, as I showed you from uname -a, also you can say this one is Ubuntu. So os-release, if you look at this file, and then you can see this is the Linux Ubuntu version 22.04, and the code name is Jemmy Jellyfish. It's a long-term support. So by knowing this is a Linux Ubuntu 22.04.2 long-term support, then I know that what file system are supported on it, and how do I know that one? So there's a file here called etc fstab file, cat file system table. That's what this fstab stands for, file system table. So if you say cat -n etc fstab file, you can, sorry, cat -n etc fstab file, you can see the file is having these disk getting mounted as /root partition and temp file system and so on. All of those ones that are mounted, whether you have some kind of VFAT or some kind of extended 4 or XFS, the type of file system are all shown up here. So if I do here df-h by itself, I don't see the type of file system. But here all I see is this temp file system, temporary, and this is root. But if I want to know by type, I can do a df-ht for type. And then if I say, just show me XFS, then if there's anything with XFS, it will show. But since that's not there, the extended 4 is the root file system. So notice if I do a grep -i extended 4 on etc fstab file, that is just where this file system gets mounted. The UUID is a unique name for this label. That is the label ID of that device, and then it's saying that mounted as root, the root partition, and then just the type is extended 4 file system. So if I just look at the tempfs file system, like these ones are tempfs file system, and there, then all I have to do is, instead of just doing like the tempfs, that will not show here, but if I do df-ht tempfs, then it's going to show all the mounted file system that are tempfs. And also there's a command called mount, and it shows all what is mounted there. And so etc mnt tab, sorry, let's start etc, let's see if this one has that one or not. Tab fstab is $mnt mtab. Mtab is showing basically what is mounted already. So when you type in mount, it is all list of these ones. And then if you see mtab, if I look at this one, if you see mtab, it is just on the proc file system self mounts what is mounted there. You can see by typing this command, catting that file is similar to typing mount command. And if I do ls minus l etc mtab, that file is in the proc file system. So if I just say cat etc proc self mounts, that is sorry slash okay, let's do ls minus l etc dot dot, and then on that one go to the proc. Is there proc? Yeah. So this tells you that that one is in the proc file system. I just need to look at that one. Sorry, let me just do this. Clear screen. ls minus ld etc mtab file of etc mtab. So you can see it is saying that L, meaning that this is a symbolic link, and this pointer is saying that go to the parent directory of mtab, and which is etc. So the file should be under the etc proc self and then mounts. That is no such file or directory. Let me see etc dot dot slash proc slash self. Okay, so that one is actually on the proc file system. This is the process ID for it that is actually seeing that one. So ps minus efa grep minus I 3941 41, and that is the one that I grep out. So let me just do one thing here. cd to self directory. See what's going on here. Yeah, there's a number of those ones, and then mount might be there. Yeah, mounts is there. So maybe I was typing the mounts inaccurately. Mounts like that, no such file. So ls minus ld mounts, it is there. And since it's a proc file system, this one is 0, which means it's a pseudo file system. So if I say cat mounts here, you will see the same file here. Whether I do mounts or say I'm sorry, mount, or just say cat mounts, and then that is showing all the file system details that are mounted. So ls minus ld mounts, and then mount command will show that one, and cat mounts from this directory will show that one also. But notice that again, this is for a proc file system. So one of the file system is the proc file system, which is pseudo based file system, which is memory based. So the file size is 0 byte, but reads it from the memory. Similarly, the proc meminfo, this file is also 0 byte, and so does CPU info. All these files are 0 byte files because the contents of them are from memory. But if I say cat minus n proc mem info, and look and notice that it reads that many 52 lines from memory. Similarly, if I say cat minus n CPU info, it reads 104 lines from the content of memory. So even though it says 0 byte file, and if you look at this cat command, just change this one to ls minus ld, you will see that the size of the file is 0 byte. So where that information is coming from when you cat it, basically it is coming from content of memory. So they're called pseudo file system. But tempfs is a temporary file system, df-hi type, and then tempfs will show this one. So by default, if you don't give any type, you can get all of them that are listed on that are mounted currently. And this is showing what device is mounted as what, and what are the size of them, and how much is used, how much is free available. So in general, every system has a file system, right? So if you just look at fdisk, there's a command called lsblock, block of the devices. Notice all the devices that are here. They're called loopback interface and other ones that are there. But DA, SCSI disk A and SCSI disk A2, this is partition 1, partition 2. On Windows, they're called C drive and D drive and so on. Logical drive here, they're called partition 1, partition. So SDA as the name of the disk, the partition 1, partition 2, partition 3, the primary partition, and then a logical drive, and other ones you can do it. And then there's the type of them. So there's also a command parted D. Parted D is just also giving you information. So I'm not gonna do anything with parted D. Let me just quit out of this, but okay, cancel. And then what we are going to do is look at fdisk. fdisk-l dev/sda. So right now I'm getting permission denied because I'm not root. So I'm gonna do sudo su dash, and I'm gonna just type in my password. Now I am root. Clear screen. I'm by default, because I did sudo su dash there. I already with that dash, meaning that run my root profile. So I'm already with the root profile, and you can see that I'm logged on as root, and my groups is showing you also root. So at this time, if I just go to look at the disk, I can say fdisk-l dev/sda. You can see the devices that are there. And then the type of file system depends on the operating system. So if I just go say fdisk dev/sda, for example, dev/sda is one of the device that has this. Then I can just say, okay, just go to that one, and I want to print it out to see what are the partition tables. So by P for printing, and I type in fdisk followed by the command. If you don't know fdisk, please don't just go there and create a device, and you might corrupt the file system and cause a problem on your system, and just your system might not boot if you write unintentionally on the wrong sector. So don't play around with parted D or fdisk or on Windows disk part partition. So on this one, when you're doing it on Solaris, there's a format command similar to fdisk. Fdisk is also provided on the x86 platform, but on a Spark architecture, we used to use a format command there. On Windows also, there's a device manager. You create the device, and you basically format the disk and everything. The disks that are just originally created, they might be raw disk, since there's no partition is created, but then the partition has no file system type. In order to get a list of what is available on this list, you just type in M for help, and you can see it has a number of them, right? And then if you just want to type in all the commands, or you can see one of them is L for list of the types. So sorry, quit out of this one first. Clear my screen. I don't see it on the bottom one as clear while I'm typing. Okay, so fdisk dev/sda. Let me just do SDA for now, just to show you. So here, if I just say list or type, T for partition type. So if I just say I want to just do a partition 3 and then type of this, you can see L is there for list all of them. So if you just want to get the list of all the partition that are available, you can see the numbers associated with all of them, whether it's Linux or HPUX or Microsoft or VFAT or and TFS or Linux or Solaris, and there's all kind of file system type, and these are the numbers for associated with them. The default one, the aliases or their Linux also, swap, home, and UEFI, and so on. All of them are there. So you can create the file system type based on that one. But at this time, I'm going to quit this one. If you create it, obviously, you do the M for help, and this print this help menu. The N is for creating a new partition, and then P is for printing. And then once you have done, you're absolutely sure you want to save the information, W for write. But you don't want to do anything, so I'm going to quit here. And then now I'm going to show you on the raw disk that was there, if how this system become tempfs, for example. df dash, not tempfs, extended 4. Dash T extended 4, you can see grep minus I extended 4 on the etcfs tab file. So you can see that the extended 4 is the latest for all those extended 2, 3, and 4. But there's a buffer file system, there's XFS, there's a lot of them. ZFS on the Solaris and Mac, there's UFS on the Unix side, and there's NTFS for Windows, and FAT32, all of them. So how do I get a list of those types also on Linux? And there's a command called makefs. So if I say which makefs, it is on user sben makefs. This is the generic makefs, make file system. So if I say type of user sben makefs, this is a symbolic link, or actually it's a binary. The type is there, file of user sben mkfs. It's an executable link format, so it's not symbolic link. It is just a binary. The type of this file is a binary, and opposed to a source file or text file or data file. Binaries are executable, and then when you compile them, then they become a binary file that you just executed. And the type of file is called executable link format. And this is for 64-bit registers operating system that are supported with 64-bit like Linux. So if I do makefs, that one is done. Clear screen. If you see mkfs star, let's minus L user sben makefs star. Notice there's a number of other file system that supports it. So this binary is called mkfs.buffer file system. And then there's CRAMFS, extended 2 file system, extended 3, extended 4, and then FAT for DOS format, Minix for Minix version of Linux, MS-DOS for Microsoft DOS version, and TFS for Windows NT, VFAT for virtual FAT file system. So all of this file system, you can also do a man makefs, clear screen, man makefs. This will just tell you that makefs by default has the option to just compile, create the file system with the option of T minus T type, and then you give the type. So if you use this one, you could just say makefs, and then minus T, let's say XFS as dev / let's say SDB1, and then just if you want to create this one, this rod device that you have mounted under your system, it will just create it with this option as well, makefs.xfs. As well as if you just say makefs.xfs, that would be the same thing as -t space xfs. Or if you do extended for file system here, by default it is extended to when you run makefs. But if you want to just get it as extended to, you could do it this way, or you could just say -t extended to. But if you don't want the default one, then you could do -t extended for, or just run the makefs.extended for, this binary. So for each one of them, there is a dot. If you don't do the dot, then means that you're going to do -t. The generic makefs is the one that you're going to do -t type and then extended for files to do this disk. Now, I haven't shown you how to create a file system on the system. The file system that we have mounted is already on the etc fstab file, and we have a root partition and that has these files in it. On the file system, normally, whenever you create a file system, you create folders and directories, and that's what a file system is. But the file system has inode structure to just have a super block and all the secondary blocks of inodes that keeps information about the files, the file size, all the attributes that are saved for the file in directory or saved in the inode data structure. And that's a C data structure. So the inode, for example, if I do a df-h, you don't see the inode information here. But if I say df-hi, then show me the inode number, you see that there's 2.0 million inodes for the run and all the other ones. And then there's inode used is that much, and 2 million inode is free. That means we can create that many inode on each of these file systems that are there. And so if I go to the /user directory, for example, and then look at the sben, the type of files are important also. On the type of file system that are there, so if I just go, maybe I should go back to the root partition and just say ls. And notice that there's a lot of directories here. Some directories are based on the system binaries like sben. Some of them are user binaries. Some of them are for booting the system, cd-rom, /home for home file, etc. for all the configuration file, the devices, and the lab for general lab, user lab, or lab 32 for 32-bit, lab 64-bit, and then lab extended 32, lost and found when there's corruption in the file system. These files are getting saved. The inode this structure is saved in the lost and found directory, so you can save it. The media directory is for the cd-rom and other floppy drives that you could do it. /mnt is a temporary mount that you can create. /optional opt is for creating like partition that you can just run application and other stuff similar to /home. Some people put everything on /opt, but only user profile stuff on /home. And the proc file system I mentioned to you earlier, that's a file system for based on memory. And root file system is /root is the root, the home directory of the root. And then run is everything that is running on the system. There's a log file for them. sben is the system binary. sdb1, sdb2 is the one that I created. Snap is for based on the Ubuntu version. And then there's also a Snap package manager, Snap list. You can see all the packages that are installed. And then here we are looking at the Snap, and then serve, swap file, and sys. They're just based on the name. The var partition is very important. The user is very important. Temporary file system templates is also based on memories most of the time. Pseudo file system. The var is the variant data structures or file directories, var log and other stuff that are kept here. And the user is everything related to user. So user have a lot of user include, user lab, user local, and then user source, user share, and a lot of other stuff, games and binaries. So what is under the binary user bin mostly is executable. User bin star, you can see they're all executable link format, the type of them. So they are binary. If they are shell script, when you type in the shell script, they are like zless. This command is a shell script. So if I say file user bin zless, it says the ASCII shell script, right? That means I can do a cat -n user bin zless, and that will show exactly the source of that ZSH, ZLS program. But at the same time, if I go on my directory structure here, the user home, /home, I might have some file under Wahid directory, and then yes, I do. And so under the shells, clear screen here, notice every file that I have .sh are shell scripts. So if I say file store.sh, it will tell you that born again shell. These are shell, that means it's ASCII text. That means I can look at the content of these files. Like let's say cat -l helper.sh, you can see that it is a shell script. And similarly, if I go to another type of file, let's say I'm going to go to, do I have programs here? Public. I don't think I have Apache. Let me see. Shells. Yeah, I might not have it here. So let me just log into the Linux Ubuntu server on production environment. So I'll just SSH to that server in a second. So I'll show you how to SSH to the server as well. I'll just actually pause the video, SSH to that one, then I'll come back and share with you. Just give me a second. Okay, so I've logged on to my web university on the cloud. So if you type in host name, you can see I'm on mywebuniversity.com website. And if I just go to do a PWD, I'm going to just go to programs. And then here I have some programs that are all kind of source code and everything. So if I just go to, for example, C++ executable files, if I just do here ls-l, notice store.c++, all these files are file type of C++, as you can see, C++ or C source code, depending on what is in the content inside the source code. So if you look at the date.c++ or environment.c++, all of them are showing an executable link format, right? So if I do want to see the executable file, like for example, for hello.c++, right? Or for demo.c++. Let me look at the for demo. For demo.c++. If I just do a file for demo.c++, this is showing a C++ source code. So cat -n for demo.c++ has a C source code, which is stored with this common multi-line comments, and it has the name of the programmer, and then the include IO stream starts here using namespace standard IO, and the actual for statement follows the 26 lines, and it's doing some kind of odd and even numbers, right? So it is looking at that one. So in order for me to look at that one, I did this file, and it shows that it's source code. So if I just say, okay, this source code, now I could see the content of it as well with a cat command. But this type of the file is different than if I compile this one, G++, which is the G++ dash version, is going to show me the compiler for GNU C collection, C++ connection compiler. For C is GCC, GCC dash version, and for the C++ is G++. So if I just compile this source code, I could say G++ minus O, and give the name for demo as executable, and then the name of the source code is for demo.c++. That is telling the G++ compiler create an output file called for demo, and from this source code file for demo.c++. So now I just created the for demo, and echo $0 is successful. That means the for demo the file got created. So if I say file for a demo, this is an executable link format based on the 64-bit type of this file. So let me just do this again. When you do this command, it tells you it's an executable link format. Earlier, I told you uname-m, machine type is x64. That is the 64-bit. And then executable link format, and that's saying that it's shared with this Linux, all of those shared object files, shared object file Linux, and then other ones also here. So if I do LDD on for demo binary, then you can see that it is using those user lib, the one that I was showing you on the user lib, and user include all of those ones, the IO stream and everything. Like libc is lib standard C, libm for math module, and all of that one is there. libgcc is for the C compilers, and then libm for math, and then libc for C compiler, and lib standard C++ is the standard C++. So it is getting linked with those ones. Now the content of the file cat-n for demo.c++, you can see here I'm running a for statement. This for statement is looking for a max dash store. So max is getting 1000, and the start is with 100. So on the within the for statement, I'm going with I is equal 100, and then incremented by whatever number plus 5 here. We're supposed to get the output of it like that. So for demo, now the executable is there. When you run it with this syntax, because this file for demo, when I compile it, the compiler automatically says this is the executable link format, and then ls-ld for demo, it just made this read, write, execute, and read and execute kind of formation. This is for the first three is by the owner, which is wlutfi has read, write, execute permission. The group read, write, execute, which is also the group name, and then other people that are not belong to the owner or the group and the same group, they have only read and execute permission. They should not modify the file. So that is perfectly good. And then if you look at this ls-ld, that one is saying that, okay, since I have the executable bit set, so for demo is gonna, sorry, for demo. Let me clear the screen again. for dot slash for demo, and then that would run those numbers there. So if I make a modification on the source code, and now I have to compile it again. This shows for the compiler kind of programming language. Similarly, if I go here on the .c directory structure and look at files that are .c extension, so here is a for demo and underscore demo1.c is another program that might say that, but file store.c is here. So cat for underscore demo1.c, you can see the IO stream is included. Another IO stream, in this case, I'm including the standard IO knowledge here, and then the printf statement instead of cout stuff, and there's no scope resolution here. So you can see this one is there. If I just say GCC dash version, that's the compiler for C. So I say GCC dash O for output, and the name of the source code is for underscore demo1.c. So I'm going to give it the same name, for underscore demo1.c. Now I just created that file for underscore demo1, and then it will just run those statement based on what the source code is. So if I say file for underscore demo star, notice that one is dot demo1 star, demo1 dot c is source code, but demo1 is executable link format. So there are different types. One is a binary file, and that is compiled with the G++ or GCC. The other one is a source code that's written within the editorial. So there are different ways to manipulate the file also, based on the VI or BEM or code or something, whether you're on Windows, Notepad or something, the file system gets created. Now the file system itself, the /home, for example, is one of the file system right here. So if I just go to my home directory on mywebuniversity.com, you can see that's my file system. And if I just go here and just go on my development, that is my file system here for home directory here. So if I just look at this one, and you can see the list of files that are there, and then if I just say file start, all kind of directories and empty files, ASCII text file and binary files, everything that are there are going to show up. So we do know that file systems support all kind of files: text file, ASCII, binary, executable, images, graphics, all kind of files, right? Bitmap and so on. So let's get to the Linux file system here. So the Linux file system, there's also a file manager that supports it. So on Linux, on Linux Ubuntu, for example, you have this file manager that you just click on it, and you could just go through your files from the graphical user interface. For example, on /home, I could have this Apache directory or this other directory. All of these ones are directories that I could just go there, like documents in here. If it is empty, I can right click and say new folder, say a new folder, and then you just create that one. And if you want to rename it, it has these options that you can just do a rename, say test1, you just rename it. And if you just right click and say I don't need it, delete it, you can delete it as move to trash, and it will be gone there. So on the file system, you can just create, right click here, new folder, and say test2, you just create test2, and then move it to the trash. You can move it, or move it to a different directory structure. You could do that one, or right click here, move to trash, gone. So the file system here, the directory structure, very easy. Whatever you do on the command line is also easy. So on the command line, if I'm on the home directory, I do ls minus l. It's almost like a listing of these ones like here. So there's a one called Apache 2. Here I double click on it to open it. Here I say ls minus l Apache 2, and that will show the content of it is there. So if I want to just go to this one, here I go to it, and then here I say cd to Apache 2. And now if I say ls minus l, it shows the same directory that are showing here under that one. So Apache 2, and let me just go to Apache 2, and then this is the directory. So now I'm on the, I need to go to the source left directory. So httpd, now I'm in source left directory. If I want to cd to source left, I notice I type in star here, meaning that I don't care after that one, there's no uniqueness. So anything that matches, go to that directory. Screen minus L now is there. So if I go look at the APR underscore icon, then it's all of that one, ls minus L. Similarly, here on the graphical user interface, you click on the APR icon and you see all of those things. And then if you want to say what type of those files are, each one of them are Apache source code that you compile it and build it. So, and these are the files that are there. There's like dependency files and make files and so on, the license and everything. So that is for the directory structure and file system. Similarly, if you are just on the home directory and you just create a directory, for example, in the shells directory, and I just want to create a new shell script, I say vim new one.sh. So now I'm just going to say pound shebang user ben env bash, and then I'm going to write a for statement, say for num and let's do it 1 through 10, and then just say do, and we say we're gonna just write a code here. Num is equal $num, and then that's good enough. And then this is too much space here, so I'm gonna take the space out, and that's good enough here, and maybe a little bit more. So we are printing that one, and then we're gonna print a new line character here, and then we're gonna say echo here minus n for minus e for expression, and then slash new line character. So we do that one, and then just since we are inside the for statement, we are done with this. So let's see, we're gonna just save this one, WQ, write it, and now we have new one.sh is created. So file new one.sh, it is executable ASCII text file, which is a born again shell hash. Because of the line the head minus one, new one.sh, I wrote this user ben env. This is a file of binary user ben env, and that is going to find the bash interpreter, which bash. So this line of syntax, which I wrote on the first line of the script, it says shebang. It says find first user ben env, which is this executable link format file, and then it's gonna find the bash interpreter, which is user ben bash. Is gonna find that one and load it. The next line under the name new one.sh is basically this for statement. After this line, it says any syntax that it is bash interpreted line by line. Since this is a bash script, this for statement has to have the syntax correctly with bash. This for num is the variable that I create n, and sequence is 1 to 10. So if I just want to run this one, I'm going to say bash minus x new one.sh is going to run that line. But I don't want to see this every statement that is there line by line on one of them. So I say for I'm sorry, new one $h. I'm gonna just show you that this is not executable. That's why I wrote it with bash -x, meaning compile it in debug mode. But I could say change mode 755 new one $h. Now I have created the permission of the file new one. Notice the color changed because of this executable. This X meaning that make it executable so I can run it from the command line. So all I have to do is new one $h. Now I can run it and the output will show based on the lines. So the new line characters, if I say them new one $h, this echo already has that information. I don't need to put another new line character here. So I could say just run it now, and it is shortened. So if I want to modify that one, for example, them new one $h, and notice this is source code. So I could say just go ahead, do this one and backtick a sequence. Let's say go 10 to 5 and then 50. So this one is saying that it start from 10 and then increment with 5 up to 50. That is a step of 5. Let's see if we could do that one and then get the output the same way or not. And new one $h, and yeah, that's how it works. So cat new one $h. This for statement on sequence basically works like a range function in Python. So if I say, and now this is the shell script, I could do equivalent to that one with Python. So now say which Python is also Python 3 version. It is 3.10.6 as an interpreter I have there. So if I just copy new one $h, temporary say new one .py for Python, and then vim new one .py. Now this is not gonna, if I just do this one and then try to run Python here, Python 3, this is not syntax is correct for Python. So let me just compile this one and say new one .py. It's gonna just say, wait a minute, Python 2, which Python 3 is there. Okay, vim new one .py. So I'm gonna say not Python 2, Python 3. So Python 3, and then if I just clear the screen, cat new one .py, this one is telling me that it is a Python script, but the syntax is bash. So if I just run this one, new one .py, it should complain saying that, wait a minute, on line 3, you're saying that this command, this is not a Python syntax. So how we correct it in valid syntax? So you say vim and new one .py, and you just change this one. And then in this case, we say for num and range, and then put a function, and then start it with 5, with 10, comma 5, comma 50, comma 5. The Python range function works that it says from the start bit to the end with increment of 5. And then right here is a separator. There's no do statement. So, and then also the next line is supposed to go 4 characters into the right. So 1, 2, 3, 4. So we're gonna move this one to the 4. There's no done. And then we're gonna say there's no echo statement. We're gonna say print statement. And then Python 3 has this bracket. Python 2, you don't have to put the parentheses, it works. but this one is going to say this. And notice this one is I'm going to use the f format function. So I'm going to say f num, and then this will print it out to that one. I don't need to just put $sign there. I think that's it. So let me just make the screen a little bit bigger. Okay, that's good enough. So tab new 1.5. I want to validate for num and range 10, 50, this print f and then that code and then num. So now if I say new 1.5, it will just do the exact thing that new 1 and .sh do. One is file new 1.sh is shell script. On the other hand, file new 1.py is a Python script. You can see that it's ASCII Python script here. So the thing that you should learn, let me do export ps1 is equal. I'm going to make that prompt shell a little bit smaller. So if I just cut this one to a short, then this would be more meaningful to you. So now let's look at the content of new 1.sh. This one is a simple file for new 1.sh that is executable file. So ls-ld new 1.sh, you can see the executable is set. So I could say file new 1.sh and it will compile. But on the other hand, this is a born again shell script. On the other one, file new 1.py is a Python shell script. So cat -n new 1.py. Notice the first line has the shebang user Benny and B, which loads the Python 3 interpreter. And then after line 2, which is blank, line 3, it uses a for statement that is the syntax of Python. On the other hand, where we were looking at the shell script was the syntax of this. So one is a born again shell. The file system supports all kind of type of files. The shell script or ASCII text source code. Some of them are based on ASCII text, like JavaScript, Java, source, and then Python, C, C++. But then there's compiled languages like C and C++, and there's bytecode, which is object-oriented like Java. And then there's like JavaScript, which is just source code and text, and that you write it inside HTML. So all kind of different file here. Now notice this one, if I just run for a new 1.py, it will just do the same thing that the other one was doing it from 10 to 50, and here is 10 to 50 to 45. Notice the range function here does not show the last one. If you want to show the last one, here we did the sequence on the step, so it includes the last one also. But on the range function, if you want to just make 50 included, then you have to go 55 or 51. So the last one is not reached to that one. So like vim new 1.sh, and then instead of 50, I could search for 50 and just change this one to 51, and then run the same script again. Now you can see 45 is included, but maybe I need to do 55 because the number 51 is not reached there yet. So let's do 55. Oh, sorry, I did it on the bash, that's why. So the bash did not need to be changed. The vim new 1.5. This one is the one that is the reach. So 51 should have been working for it. And then you can see this 50 is included because one number bigger than the 50 will just reach to that. So we're good with that one. New 1.sh, and and new one.py, file new one.sh and new one.py. One is shell script, born again shell. The other one is a Python. The syntax is different, as you can see there. Their source code that are both interpreter. One is Bash interpreter, and the other one is Python interpreter that reads the line by line and it does it. On the other hand, the one that I showed you for C and C++, their compile language, the whole entire source code is read at once, given to the compiler, then it gets to the loader, and then linker, and then it creates the object file. From object file, it creates the executable link format. You run the executable link format, and you get the output in binary. I mean, the output of the binary file as the executable. And so this is all kind of file types there. So at the same time, you have HTML file. Let me just go here again on the var www.html directory. Like for example, on the index.html file, if I look at my index.html file, this is my source file for mywebuniversity.com that you're looking at. So if I look at this HTML file for index.html, you can see this is a file type of HTML document. So if I go to the YouTube, I mean my web university, and just say www.mywebuniversity.com, this is the page that comes in. And then at the same time, if I just go on the temp file system, make a directory, so I say new one and cd to new one, and then I say, is there any file? No. So I could say wget https and then www.mywebuniversity.com, and then the index.html file comes in. So notice that this file, it actually, it says -- no check certificate, because the wget is actually, you have to put that syntax with, because it's a secure page, -- no check certificate. And that means that don't check for the certificate. Now index.html file comes in, and then inside this directory, now I have an index.html file, the same file that I just showed you from the board of the .html. You can also use curl to get that one. So curl -o for the output file, index wahid, whatever you name it, index.html. If you don't give it any name by default, it is just written to the name that was supposed to be saved, since it is coming up here and the file is already here. If I want to just rm index.html, or if I just say -o here, -o, and then give an index.html file here, and since it's already there, it just overwritten it with that. If I say rm index.html, then run this command again, now there's not one, but it is coming as a download as a result. So rm index.html, and then I could just give it a new name like -o index underscore w for wahid. So notice the file more index underscore w.html as the contents of my website. But because this is a directory that I don't need, I'm going to remove it. Remove a file like this on the, I don't have any other files. I say rm start, it will do it. So I can say ls-ld new one. This is a directory. Notice the content of this one shows you it's a directory D, and then I'm going to say rm dir new one. Now it's gone. So now in the temp directory, there's no nothing as new one. So on the fly, you can create directories, you can create files, and just do it because you have a great file system. So I showed you a lot of things with the file system. Now, how would you create a raw device, and how would you share them? I'm going to show you that next. So let's go to a Windows platform, and this one I'm going to go to a file manager of Windows. So if I just close this one and close this one, and if I just click on this one, this is the file manager equivalent, the one that I click here on the Linux. On Windows, you have this file manager, this file explorer, and the yellow icon that is there. So you click on this one, it opens up the Windows File Manager. On the Windows File Manager, you can also have the NTFS file system, and XFS, and a lot of other file systems that are by the file system, whatever is supported, that you will be able to see the file system. But on the disk here, you also have fdisk command line from the command lines similar to the Linux. Fdisk is the utility, but if fdisk is no longer provided here, you could do disk partition. This partition, it will say, do you want to allow this one? You say yes. Now that this partition comes in. This is like fdisk equivalent or ported D equivalent for the Linux. So if I say help here, there's a list of the devices here. And then if I say list disk, you can see that disk 0 is there. And if I say help list, you can see all the options with the disk, partition, volume, and virtual disk. So I don't have any virtual disk. So if I say list virtual disk, it say there are no virtual disks. But if I say list volume, then the C drive and other file systems are shown here. If I say list a disk, then it shows me disk 1, which is a 953 gig, which is my C drive. So if I want to get the partition on that one, I have to use the select command. The select command is basically you select the disk. If I just say list partition, it says you haven't chosen the disk. You have to choose the disk first. So you select a disk, and then since it's disk 0, select disk. There are no disks. Let me just say disk 0. And now disk 0 is selected. When the disk 0 is selected, the disk partition, now you can say list partition, and it will show the partition on the C drive. And you can see the partition, a total of 952 gig or 982 gig is the size, and 952 is available, and all the information. You can also get that information if I exit out of this one and then do a bigger screen here. I can also do a directory here. You can see the C drive here, and how much free is available and how much is these directories are taking on each one of them. You can also go on the current computer here, this PC, and right click here and go under properties, and you get that information here. The total of user space and what's free, how much is a total on all of that. Okay, and then at the same time, you can just want to share between a Windows machine and a Linux machine. And this particular, I'm going to show you Linux Ubuntu. So I just wanted to go on my C drive under users, under my home directory Wahid, and I have this programs somewhere here. Let me just see. I'm going to type in P so I can see programs here. And this programs, actually, I just shared it. So if you right click on the programs and say properties, and under shared, you just say share this one. When you click on share, you just share it as this host name at this mount point and all that information. Earlier I did that one, so now this one is already showing it is shared. So if I just want to do another one, I could do that one. Let me just do another one just to show you how you can create something. So under the let's do it under the temp directory. Right here, temp. I'm gonna create a directory first, say new, and then I'm gonna call it shared folder. So this shared folder right now is empty. I right click on it and then click on properties, and I click on sharing. Then I say share it, and then I just choose people to share, add, and this is the Gmail account, and choose people to account. So you can choose to share a folder. One second, let me make sure that I have to actually do it on the Linux side. This is okay. I just don't have to do this one on this part. I could do it on the Linux Ubuntu. So I'm gonna shut down this Linux Ubuntu first. But before I do that, one I have already created, let me just show you the part that I have already created first, and then I'll just show you the other part after. So right here, under the, when you click on the file manager, if you click at right here, share folder programs, I have already shared it here. So this is the entire programs that I shared earlier that I showed you here under the users, programs, users, Wahid, and then programs. So right here, if I right click here, say new directory, new, and then folder, and I'm gonna just create a directory called, let's say, Windows dir1. So I'm gonna call it dir1 for Windows directory 1. So here I just create this one, and I want to just right click here, say, let's open in terminal, and then this one is going to open the same one in Notepad. If I do a directory here, nothing is there. I'm going to say Notepad, or just say echo directory for Windows. And I'm going to just say create this one and say their Windows dir one .text, just the some file that I created. So type Windows underscore dir1.txt. This command echo just created this information and it wrote it there. And now if I come here, it has this file Windows directory for Windows. So I can see that file from Windows, but since I shared this folder, I should be able to go to my Linux Ubuntu and see the same thing. So I go here, the directory, I call it something like Windows share something. Let me just remember the name. The name Windows dir1. Under the programs, Windows dir1. So I'm coming back here on the file manager, and then Windows dir1. So if I right click here and say, actually go out one time and then come back here, and that would refresh it. And then I should see Windows dir1 somewhere here. Yeah, right here. So Windows dir1, in the content of that file, I could see it, it is there. So now if I just go out here, or let's go one directory out, and I could even do it from command line, but like right here, I could just click anywhere here and say open in terminal. Open a new window, open location, and it is opening that location. So you could do that one like that as well. So cd to home directory, ls -l, clear screen, programs, Notice the programs are here. That might be the same one as the Windows directory. Let's minus LTR. Okay, this is the other one. Windows. Text. News files and okay. So let me just go to the file manager and then go under programs and then Windows dir1 here. I'm going to right click here, it says open in terminal, and notice that the media is that the place where it gets mounted. So df-h, it is under this media shared folder programs is the same as that one. And so I could say cd to media shared folder underscore programs, and now I can see it from Linux also. Same thing. Similar to the GUI here you could see it easily, but here under the media it gets mounted. So all the directories that are there, you're seeing here. So Windows dir1 is there. And if I just say clear the screen here, pwd, since Ubuntu dir1 is not there, I could say make dir Ubuntu dir1, and now I create this one. I'm going to attach a file, say ls-l, and I'm going to say go to Ubuntu dir1, and I'm going to touch something and say echo. This is from Ubuntu. Ubuntu. And then I'm going to greater sign Ubuntu .text. Ubuntu .text. Doesn't matter what you name it. So cat minus n Ubuntu .text is gonna cat minus n Ubuntu .text. I might have typed it differently. So let's look at that one, and then it is there. On the Windows side, if I go on the file manager, I should see this folder also, because the share folder have read write for both of them. So now I want to show you how I made that one possible. First, I'm going to show you the Ubuntu, and then this is the file that it says this is a Ubuntu file. And you can just go add it or rename it or anything. You have right access there. Don't save and then don't save. So there's a couple of things on Linux Ubuntu that you have to do to do that one. First, there's a group name, cd, clear screen, export. Yes, let me see. This is pwd, clear screen, pwd. Okay, so if I say export, ps1 is equal and $, and then clear screen here. If I'm on this directory, first I have to say id-un is Wahid. Who am I is also showing Wahid. What I did was just make sure on Ubuntu, I just allow the user Wahid to be part of the VirtualBox share folder group. So there's a group name called VirtualBox, VirtualBox, and then FS share folder, etc group file. So this is the one that I had to add this one. And the command to do that one, you have to be root first. Sudo su dash. I'm going to become root. And I'm just gonna say GNU pass WD, G pass WD minus D Wahid from VirtualBox share folder. Now I deleted that one. So if I just do that grep minus I again, that grep minus I, virtual box share folder on etc group. You see Wahid does not belong to that group. That means that if I just go to that share folder, when I reboot the system and that group, I cannot see that one. But because I have already brought the system up, I can see it. So what I'm going to do is make sure that I'm part of that group. Either you can VI the etc group file and add yourself on that one, or use the group pass wd g pass wd minus d Wahid, and then virtual box, and instead of minus d, removing it, minus a for add Wahid virtual box, etc. Now it is adding it, and now if I do a grep minus I, it shows there. That means I have a privilege to share that folder. But that share folder, I'm going to shut down the system, okay, in order to show you what I did on the Ubuntu side, the virtual machine. So I'm going to exit out of all of this and then log out here, power off, log out, say yes, log out, and then power off. Yes, power off. So the system is now power off, and then you can see on the virtual machine that this is power off. And so what I did under the setting here on the virtual box setting, there's a shared folder here. So I click on user Wahid, I click on this plus, and then I went to the folder. I choose this C drive user Wahid programs, and then I gave the name of that one also as like this. So this is what I did here first. Under the programs, I choose the folder, and then I give it the same name, programs, and then I choose the auto mount, meaning that as soon as the my web university Linux Ubuntu powers on, it automatically should mount it this directory. So the two directories are shared between the Linux and Windows file system. That is how you look at it, okay? So that is for that one. Now I have showed you everything on the file system that I wanted to show you. What I want to also show you on the setting, there's an option here if you want to add an additional raw disk. So you go on the storage here, and then under the SATA, not under the controller ID, under the SATA, you click here, and then there's optical, and there's disk drive. So when you do the click on the hard disk drive, notice when I'm pointing to this one, it is going to just say add hard disk. If you want to point to this one, it says add optical drive. You want to add a hard drive. So you click on this one, this interface shows up, and then you say, okay, I want to create additional hard drives. So let me just remove these other ones from the list, not attached. I'm going to click on create. I'm going to just create a new virtual box disk image, VDI file. So by default, it is selected, and this is what you want to create under the virtual box VDI file. You're going to say next here. And then the pre-allocation, leave it blank because the size grows. You don't want to do pre-allocated. If you want to do a fixed size, you can do pre-allocated in advance, but I'm going to leave it blank. And then there's 25 gig. I'm going to change the name of the disk here to, this is the location where it is written. Users Wahid VirtualBox VMs, and then for the name of the instance, which is my web university, and the VDI file with the name of the file. So I'm gonna call it 5 gig. My web university underscore 5 gig dot VDI file. So that would be that file, and then I'm gonna size it to 5 gig as I mentioned it to the name. Here, let's go to 5 gig. That's pretty close, so that's fine. 5.2, or I could just say 5.0 gigabyte. And then click finish. And then now and the disk is created this 5 gig. So now I have to choose it. And then once you choose it, it gets mounted here. And this is attached now. Now it will be seen by the Linux ls block command and fdisk command and other ones that you can create. This is a raw device. So far, the 5 gig is raw device. There's no file system. There's no partition created, nothing. You just allocated 5 gigabyte in size. There's no file system on it. And you can see that attached to nothing and then encrypted with dash dash. So I'm going to say OK. And now I'm going to start the system again. Remember to create it on under the, say the not in the EDI. If you do it by accident under EDI, you might get the information say the disk is not booting because the device is not a file system with Linux boot loader. So that's why you're going to get that message. So make sure you are doing it under SATA. So earlier I showed you a number of file system here. I'm going to open a terminal here, and then I'm going to just make this screen a little bit bigger and export PS1 first. Let's just change the PS1 to be only a pound this command clear screen, and then I'm gonna have to become root here first. Sudo dash, and then I'm gonna type in password for the sudo switch user do, and now I'm gonna say export PS1 is equal only pound, so I don't have too much detail there to just worry about it. I know where I am and what I'm using, so that's just a pound is good enough. It's less distracting. So at this time, if I just want to say fdisk dash l dev slash sd b or sda, those are the file system that are there, sdb, and they're there. So how do I know what is loaded here? I can also do ls block. ls block shows you all the SDAs as well as the new one SDB, like here the one that I mounted SDB 5 gig. This is a raw disk that we just did SDB, and then the size is 5 gig. So let me clear the screen here, and then I'm gonna do ls block grep -i SDB, and then that's the disk that we have 5 gig that we want to see on that one. And you can do also ls block and then tail minus 10 to see the last lines. I think after this is 1 line, 2, 3, 4, 5, 6, 7, 8. Let's just make 8 of them, or -5 of them. See what? Yeah, 5 is good enough, or 6. So SDA1 is also there. And then you can see SDB is the device there. So if I say fdisk minus L dev slash SDB, you could see that this is a raw device. It does not have any file system on it. And if I just go to it and say fdisk dev slash SDB, then it's going to say, okay, this is not having any partition yet. Do you want to create it? And the command M is going to list all the commands that are there. So if I just don't want to do that one, I could quit out of it. But if I want to do it, I could say new for a new, and then now I could say P for primary, and then it says, okay, you want to create that one on the first as the primary. And then I say, yeah, starting sector with 2048. And then if I just say exactly all 5 is allocated, 5 gig, and then I press enter because the last sector is there. Now, if I say P for print, SDB1, it is just created as a Linux file system by default. So now if I want to write to it, and then I can just write to it, say W for write, and now the partition is created for this one. So now dev SDB1, it is just a file system, and notice it's a B for block file system. So dev slash SDB1 is there, file dev SDB1 is a block special, and this is the major number, this is the minor number, and all that, the details are there. So at this time, if I just want to say, okay, and this file is there, but how do I mount it there? In order to mount it, you have to create a mount points directory on the machine. So I could say make dir slash SDB1. And if the directory already exists, obviously, I had created earlier, so I'm going to do rmdir SDB1. And then if I just say mount dev slash SDB1 as SDB1, it's going to say mount does not exist. That means you have to create make SDB1. That's why I removed it. Now, if we redo it, it's going to just say, wait a minute. Wrong file system type, bad partition, bad superblock. So it did not recognize the file system as a valid file system. In order to recognize it, you have to actually create a type on it. Remember when I created the fdisk clear screen, fdisk dev slash SDB1, if you look at the partition table, you have to say L for type, and then now you say which one you want to do the type. So quit here, clear screen. Fdisk here, you could say type, and then sorry, 3. Let me see, SDB1 was the main one. Quit out of this one, clear screen. Fdisk slash dev slash SDB1. Okay, so yeah, SDB1 already did it. So here I could say L for the type, and then just give the size. So the type for Linux is 83. So I say 83, and then unknown command. Oh, let me quit out again. Sorry, this and dash dev slash SDB here, and then I'm gonna say, be careful, okay, new M. So M is there for print the type, and I believe for type was T. Let me just see what does T do. T, yeah, T is the one that is there, but unfortunately my screen I cannot see the bottom. So let me resize it. I quit out of this one. Quit out of this one, clear screen. I'm gonna have to resize my terminal. Sorry for the problem, because I cannot see the bottom of the thing. Now I can see everything. I'm gonna this zoom menu is always on top of the bottom stuff. So I'm gonna say fdisk slash dev slash SDB SDB, and then say type. And now I'm gonna say SDB1 for type 1, L for the type, right? So select partition, selected partition is 1, and then I could say L for type, and then the type of the file system are there. But I show you an easier way to do this one, so you don't have to go back and forth between this. And then all you have to do is quit out of this one here, and use the makefs. Use the sben makefs. Make file system is going to create the file system based on the type that you provide. If you do a -T for extended 4 file system, you provide the option. So this dev and slash SDB1 is at the device, but that does not have a file system. I'm gonna create a file system called makefs minus t, and then say extended 4. By default, this extended 2 if I don't give a minus t option. Makefs by itself, if I say dev slash SDB, one, it's gonna just create the file system. Notice it adds the UIDs here that you can capture this information, put it on FSTAP file and mount it next time when you do it. So it comes on the boot time, but this is a demo. I'm not gonna mount it on the FSTAP file. I don't need to. Yet you can modify the EPC FSTAP file similar to this other one, UIDs. You just take that UID information and then you put it there, and then the root partition would be whatever the mount points you gave, SDB1 or something, and that you want to give. And then the type of it, whatever file system that it is mounted. If it's extended 4, you type in extended 4. If it is extended 2 or XFS or something, you just give it a file name. But I'm not going to do that one on this one because this is just for a demo purpose. The file that I'm talking about, df-h command that you are seeing this one. So if I just say clear screen, makefs, and then dev slash SDB1, I already created the file system earlier, and that was extended to. Notice that it creates by default extended to. I'm going to just say no, don't override it. So I'm going to say mount dev slash SDB1 as SDB1. And now if I say dev minus h dev SDB1, you can see that this is the 5.0 gig. It is written. I can cd to SDB1, and then so far no files is there. I can touch this and then look at the file this. It is there, rm this, and then echo Wahid is testing, and then greater sign test. And now I wrote the test and test file as that one. So it is there. But how do I know that the file system type by default is extended to? Remember when I created the makefs, it told me that it is a extended to file system, like right here, where the super block and all that information was given. But here I could also type extended to, and you could see that it is an extended to file system. But if I just want to see extended 4 file system, root partition, grep minus I SDA3 on etc FSTAP, that is also XFS, I mean extended 4. So if I just say show me the extended 4 on the FSTAP file, that one is showing you the root partition is extended 4. So df-ht extended 4 will show you extended 4 file system. Tempfs shows you tempfs. If I have extended 2, it will show SDB1. So now I'm going to just go back here. You mount SDB1. Now I unmounted it. It's no longer there. When I say df-h, it's not there. Anytime I want to mount it back, I have to say def SDB1 as SDB1. The mount point name is optional, but the device name has to be either the label or the actual physical device name. So now it shows up, and there again, the type of that one is extended to, and it will just show you that. So if I just want to change the file system from extended 2 to extended 4, a number of ways you can do that one. Clear screen. First, you have to go to the root directory. You mount SDB1 first. That is not mounted. And now I'm going to say makefs minus t extended 4 dev slash SDB1. So now it says this one has extended 2 file system on it. Are you sure? If you override it, the content of those files will be overwritten. So the file is not going to be the same type. And then you say, yeah, go ahead, do it, because I want different file system have different features. For example, extended for has the journal D for logging, and other ones that previous version may not have it. So that's why you want to use the newer version. So I say, yeah, go ahead and just create that as extended for file system. Now it created and it gave me a new UID. And then that way, if I mount the FS tab file, then I have to modify it based on this information. But I could have used dev/sdb1 as the name, and I don't have to type in the UID every time it changes. There's also a LSU block, and that will show you the device name with the UIDs and all that detail that you can get. And then ls block actually told you that SDB1 is 5 game is partition, right? So at this time, if I just say, okay, great, and mount this one dev/SDB1 as SDB1, but now it is mounted, I'm just going to look at it, and this mount point is actually extended for file system. So file dev/SDB1, it is showing is a block device, and then when I just create the file system here, it told me that actually it has extended to file system. You want to create it as extended for file system, yes or no? Then I said, yeah, go ahead, create it, and yes, create it. So now it is created as extended for file system. How do I know from the mount command? Clear the screen here, say df-h type extended for. So when you do extended for, it shows that SDB1 is extended for, so and that's root. Both of those ones are extended for file system. So if I go to SDB1 and then look at it, that file that I created earlier is all gone. So the lost and found may have the inode corruptions files, inode numbers that you can recover, but at this time is empty because it prompted me at the time when I wanted to create it to a different file system. And any of the file system that is under user sben make fs, you can just let me just do without the -l, so you can see the list here nicer with the names. So make fs -t, then you can just say -t for type. You can use battle file system or extended 2 or extended 3 or extended 4. Or if you intend to do battle file system, then you run this binary, make fs.bfs. If you want to make a file system with extended 4, you have an option of make fs -t type extended 4, or you could just type in this binary name. By default, it is done. Similarly for bfat, for msdot, for minix, for fat, and all of that. So if you do a man page on the one of them, for example, man make fs.ntfs, you can see that this is for a Windows NT file system. So similarly for fat file system. So notice that if I just cd here, and then you mount a /SDB1, and now I'm going to say make fs dot fat, and instead of -t, I could do a -t fat, and then or I could say -fs dot fat. Use this binary, and then dev/SDB1. So now this time it created a fat file system on it. It did not even told me that this file system has extended 4. So now if I just look at that one and say mount dev/SDB1 as SDB1, it gets mounted at df-h SDB1. You can see it is mounted there. And if I go say df-ht fat, there's no such thing as fat. So the VFAT is the type that you want to type in, virtual file allocation table. So this one, it will tell you that the EFI is there, and this is extended. Sorry, the extended what is firmware interface that is there, and also SDB1 is the one for the one that we mounted. So that type, both of them are type VFAT. So depending on the type of file system that you create, you are going to just create it. And if you don't need it, obviously you mount slash SDB1, and that gets unmounted. It's no longer there. And if I want to add it on the FSTAP file system, I just add the device name, the mount points, and then the type of file system, and it gets mounted at with time. And how you want to mount it, as read write or read only or anything, it's your choice on the FSTAP file. I hope this information helps you a number of ways to just do your work on Linux, Ubuntu, and Windows. I did not cover other Linux, Rocky, or maybe Solaris, or Linux Red Hat, or another other ones, but they're all similar. So the shared folders, you go under the shared folder on the file manager here. Make sure your VM is power off. You go under the setting, and then the share folder. You just allow that share folder, and then on the system with the group name, you added some of them. They automatically, some of them, the syntax might be share and then the name of the share folder. You share it there, and you could do it. Also, there's other options under the disk that you could do auto mount stuff for it, as well as running the VMware tools on VirtualBox. You have also for mounting stuff, and then that one I could cover next some other day. But this is all about file system. So I hope you enjoyed this video. If you haven't subscribed to our channel, please make sure you subscribe. There's a lot of good stuff here that you can learn and benefit yourself. And if you or any family members or friends and loved ones, or learning computer science related courses, and whether they're going to college or they're on computer doing some sort of cloud computing, Amazon Web Services, or writing programs, developments, operating system, share with them this knowledge and documentation and videos and everything. It will be pretty good. Nobody is perfect. There's 66,000 technical documentation that people have been writing these programs and updating it on a daily basis for the past 80 years or 60 years. So it's a lot of data there, and that you can just share with them, and they all will learn it. Take care. God bless you all. Bye.